Now we're going to discuss about a starter. Okay, what is the purpose of starter, or what is meant by starter? Okay, many of them think about it. Starter is used to start the DC motor or induction motor. Okay, but the starter is not used to start the motor. Okay, because the starter is used to limit the starting current of the motor. Here we are focusing for importance of starters and what are the types of starters available in induction motor. Okay, the starter is used to limit the starting current in induction motor at the same time to operated in safe way. Okay, different types of starters are there. Okay, one by one we are going to discuss. The first starter is a direct online starter. In this diagram, okay, in this diagram, this is our input supply, AC supply. This AC supply is connected to the stator winding of induction motor, but it's not directly connected. Okay, in the supply is first is connected to the main switch, then it's connected for two coil. One is a NVC and another one is a OLR. NVC is nothing but it is a no volt coil. Another one is a OLR is a overload release coil. Both are to limit the starting current value. Okay. The no volt coil, it to sense the output voltage. Suppose the voltage is not available. Okay. The turn off of the main switch. Otherwise, the overload relay, when the current value is more than the rated value, okay, so the overload relay is trip the main switch. Okay, this is the protection of direct online starter. Okay, the direct online starter, yeah, normally used less than 5 HB. Okay, someone asking, okay, in usually 5 HBs are available in all kind of motors. Then what is the purpose of direct online starters? Okay, that answer I will explain later. Okay, in this direct online starter having here two buttons, one is a on button, another one is a off button. Okay, through this button only the starter is start and stop mode of the motor. Okay, already we know we discussed about the two coil. One is a OLR overload release coil, another one is a NVC. Both are the protections. Okay, especially in OLR is thermal or magnetic load coil protections. Okay, NVC is something but no voltage coil protections. Okay, here the NVE is connected the direction of normally open contacts are closed and the motor is connected across the supply through the three contacts. The fourth contact server has hold on the contact which keeps NVC circuits closed even after the on push button is released. Okay, suppose the off push button is pressed at that time the NVC is de-energized. So the de-energized power is opening the main contact when the motor is overloaded. Okay, so at that time the thermal overload relay connect the control circuit that is disconnected the NV supply. All this protection is achieved thermal element overload release coil. Torque developed by the motor when started by the direct online starter. Okay, so here we are discussing about what is the relationship between torque and current. Okay, here the power of the rotor developed in output power. So it's a torque and speed. Okay, here we will calculate rotor copper losses. Rotor copper losses is nothing but it is a slip into rotor input. Otherwise, the rotor copper loss is usually calculated. The formula is square of the current into secondary resistance or rotor resistance. Both the values are equal. So here the rotor input is omega into T. The slip value is S. So S into omega into T is equal to the usual formula of rotor copper loss I squared into R2. Okay, it's equating both the equations. We get torque. Okay, torque is directly proportional to square of the secondary current. At the same time, it is a inversely proportional to the slip. So in this equation itself, we can clearly understand that, okay, stator current is directly proportional to the rotor current. Next. So the torque, the proportionality we will remove. We put proportionality constant K. So the torque is equal to K into I1 squared divided by S. Okay, in starting stage, the slip value is a 1 maximum. So in starting torque, TST is equal to K into IST square. Okay, in starting condition, the slip value is maximum. So the torque is fully dependent upon the square of the starting current. Okay, so the full load torque is directly proportional to the starting torque, as well as the square of the starting torque is directly proportional to starting torque, and the full load slip is directly proportional to the starting torque. The only thing is the full load current is inverse square of the full load current is inversely proportional to the starting torque. This is the starting torque equation of direct online starter. Okay. Then next starter is a stator resistance starter. Here the main supply is not directly connected to the stator winding through the main switch. The main switch output is the in between the main switch and the stator winding is placed stator resistance. If you are varying the resistance, automatically the voltage drop will be varying. The voltage drop will be varying. The flow of stator voltage will be varying. Through this concept only, we are reduce the starting current of starter in induction motor. Very low voltage is supplied to each phase of the winding at the start by inserting more resistance or inductance in series with the stator winding. Okay, so inductors or resistance is seriously connected. Automatically, the current flow will be reduced. As the motor picks up the speed, the small current, gradually the resistance value will be taken out of the circuits. So automatically the current value will be increasing, the flux will be increasing. So the speed will be increasing. That speed is can able to run the motor in safe way. Okay, the applied voltage across the each phases to be reduced in a some fraction amount. That fraction amount of value is indicated as a x. Okay, depend upon that x, the applied voltage of each phase will be varying. That is x into v. In starting current, IST is equal to x into ISC. Okay, here the x value is a fraction value. So the starting current will be reduced. Our ultimate aim also to reduce the starting current, because the starter is used to limit the starting current. The formula of starting torque in stator resistance starter is TST is equal to x squared into TFL into ISC divided by IFL whole squared into SF. Here, this x squared will be inserted depend upon the stator resistance value. Okay, what are the advantages of stator resistance method is smooth oscillation. Okay, because since the resistance or inductance value is gradually reduced, simple and low cost, that is a less expensive. Okay, power factor also during the starting time it's a very high, but some demerits also there. Okay, these demerits are current is to be reduced by a fraction of x, but the torque is reduced to square of that fractions. So the starting torque is very poor. That is the main drawback of stator resistance starter. Okay, at the same time, more energy losses across in the resistors or inductor preferred. So it's generating more losses in starting time. Okay, the losses will be increasing automatically. The output power also affected. Okay, in starting duration, it's taking too much amount of time compare the other starter. So its time duration also more. Okay, these so above the demerits are highly impact of the output of the motor. So the starting method is very rarely used. Okay, thank you.